sum and difference formulas. The formulas, once again, do not look nice here because it turns all the parentheses into strange symbols. But these formulas are printed in your notes. And like with our first set of formulas and identities, they do not need to be memorized. They will be provided to you when you take your test on this next week.
Do we need our calculators for this?
We will not use our calculators to solve these. So this problem says to find the exact value of the cosine of 75. If we would grab a calculator and type in cosine of 75, it's going to give us a long, messy decimal, which is not an exact value. So to find an exact value, what we want to do is think about some angles that we've worked with, that we can do stuff with, that will either add or subtract to give us the angle in the question. So what can I add or subtract that will give me 75 that are things I can work with?
45 and 30.
45 and 30. Because 45 we've got a triangle for, 30 we've got a triangle for, so those are numbers we can work with for angles. It doesn't matter what order you do them, so 45 plus 30, 30 plus 45, it doesn't make any difference at all. Now, our formulas say something more complex than what students want to do here. What students want to do here is distribute and say that it's cosine of 45 and then cosine of 30. Distributing is something that we do with a multiplication. This is not cosine times 45 plus 30. It's the cosine of a 45 plus 30. It's not a multiplication, so distributing doesn't work. But we do have a formula that we can look up on our identity sheet, which again, you don't have to have them memorized. But at the top of our notes, we would look under the sum formulas, because this is adding, and look for the one of cosine. And it says cosine of u plus v is equal to cosine u cosine v minus sine u sine v. I don't know why they use u's and v's. A lot of math formulas we use u's and v's. I think it's a bad idea because with a lot of our messy handwritings, they end up looking alike. So just be careful of what's u and what's v. So what the formula says to do is to do cosine of each value and then subtract the sine of each value. So we're going to do the cosine of 45, the cosine of 30, and then subtract the sine of 45 and the sine of 30. To find those things, we need our triangles. So 45 and 30 give us some special triangles. So in those special triangles, what is the cosine of 45?
1.
What's SOHCAHTOA for cosine? Adjacent over hypotenuse. So adjacent over 45, 90 is 1 over the square root of 2. Cosine of 30, adjacent over hypotenuse for the 30. Square root of 3 over 2. Sine of 45, what's SOHCAHTOA for sine? Opposite over hypotenuse. So what's opposite over hypotenuse in the 45, 45, 90? And opposite over hypotenuse for the 30? And order of operations says that we should multiply before we add and subtract. So when we multiply, we do not need a common denominator. We just multiply bottoms. This gives us the square root of 3 over 2 square roots of 2 minus 1 over 2 square roots of 2. You should always, at this point, have the same denominators. If your denominators are different, you've done something wrong, which is quite convenient because to add and subtract, we do need common denominators, but you should already have them. So then we can write this as just the square root of 3 minus 1 all over that common denominator of 2 squared of 2. And that's it. I like that you guys say it that way. That's it? That's it.
How's that less messy than
This is not necessarily less messy than a decimal, but it's exact. It's perfect and precise. And perfect and precise is something that we care about a lot in math. In terms of practicality, I have no clue, any idea like how big that is. So in terms of practicality, if I need to do a measurement, that means nothing to me, and a decimal might be more useful. But perfect and precise is something that we care about in math.
Do you use the triangles for every single one of these kind of questions?
Yes, we use the triangles for all of these. So this question's in radians, and I don't think well in radians, basically because they're fractions. And I'm sure a lot of you don't really think that well in radians because you just learned them not that long ago. So if your problem is radians, I would say the first thing you should do is turn that into degrees. How do we turn radians into degrees? 180 over pi. So this becomes then the tangent of 180 divided by 12, which is 15. That's a lot easier to deal with. So we're looking at adding and subtracting, sum and difference formulas today. So we want two angles we can work with that we could either add or subtract that would give us 15. Okay, I could do 45 minus 30. There's actually another option as well. What else would subtracting a 15? 60 minus 45.
So, like the 45, 30, whatever those in there, they have to equal like this number, like a 15.
Yes, we have to pick something from 60, 45, 30, or our axis angles around. So we could use 90, 180, 270 as well.
Okay.
But our goal is to add or subtract to get the number that's in the parentheses.
And those numbers are always going to be.
Yeah, it'll always work out that it'll be
add
this.
up or subtract from angles. So.
Yep. It'll always be coming from our special angles. So there are two options. We could do 45 minus 30 and 60 minus 45. One of these options is actually easier than the other, but to be honest, I don't even remember which one, and it's not something we can easily tell from the get-go. So I'm going to show you both of them because some of you may have gone with a different set. Some of you may have thought of 45 minus 30 first, others of 60 minus 45. So I'm going to show how it works out both ways, but one way is actually a little bit easier than the other. So this is a subtraction, so that's a difference formula. So we're going to look under the difference formulas for tangent. And it says tangent of u minus v is the fraction of tangent u minus tangent v all over 1 plus tangent of u times tangent of v. And nothing can be canceled there. We can't cancel parts of adding and subtracting in fractions, so it's tempting to start canceling out things that match each other, but we can't cancel out a part of adding and subtracting. So we're going to plug in now 45 and 30.
Tan, like how is this minus, would that turn into a positive because the 30 is negative? Or?
No, that already takes the subtraction into account, so we're using the 45 and the 30, not the negative. So that's a good question. Our u and our v are just the numbers themselves, not the negative in the middle. So we're going to go tangent of 45 minus tangent of 30 over 1 plus tangent of 45 times tangent of 30. So we need our same special triangles, 45, 45, 90, and 30, 60, 90. What's the tangent of 45? Remember, tangent is what for SOHCAHTOA? Opposite over adjacent. So in the 45, 45, 90, what do we get? 1 over 1, or just 1. Minus tangent of 30, opposite over adjacent there. 1 over square root of 3. This is the messier one. Over 1 plus. Then it asks us the same two things, but we're going to multiply them, so 1 times 1 over the square root of 3. which is just really 1 over the square root of 3, right? 1 times anything is itself. Now the reason why this is messier is because this would not be considered a good final answer because it has fractions inside of fractions. The way we fix fractions inside of fractions is I'm going to multiply the whole top by the square root of 3. But I'm not allowed to just change the top of a fraction. So I also need to do that same thing on the bottom because then I'm really just multiplying by what? 1. Anything over itself is 1. So on the top, we're going to distribute through, and that will give me the square root of 3 minus 1 over, on the bottom, the square root of 3 plus 1. And nothing cancels there, even though they look a whole lot alike. Since one of them's subtracting, one of them's adding, nothing cancels there. So that would be our final answer. You don't need to write this down the other way, but I'm going to show you what would have happened if you would have picked 60 minus 45 instead. So our formula then would be tangent of 60 minus tangent of 45 over 1 plus tangent 60 tangent 45. What's tangent of 60? Opposite over for the 60. Square root of 3 over 1, or just square root of 3. Tangent of 45. 1 over 1 over 1 plus, multiply those same two things, and our answer would have been done right there. So it would have saved us a step. So that would have kind of hard to tell which is easier. Not really. Not until you get into it. Questions?
Wait, how far in our notes are we going to go today?
About halfway through the notes today. All right, the next one I want you to do is sine of 15, and I want you to go ahead and give this one a shot on your own. What are two numbers I could subtract and get 15? 45 and 30, or you could do 60 and 45. And with sine and cosine, there's not actually a harder and easier one. With tangent, it can make a difference since we're working with a big fraction there in our formula. But for sine and cosine, it doesn't make a difference either way. You'd get exactly the same answer in exactly the same number of steps. The sine formula for subtraction says to do the sine of the first one, then the cosine of the second one, plus the cosine of the first one, and then the sine of the second one. It is minus. Thank you. I was looking under the wrong set there. Then from our special triangles, 45, 45, 90, what is the sine of 45? 1 over square root of 2, opposite of our hypotenuse. 30 what is the cosine? Square root of 3 over 2, adjacent of our hypotenuse. So adjacent to the 30 square root of 3 over hypotenuse of 2. Cosine of 45, adjacent over hypotenuse in the 45, 45, 90. 1 over square root of 2. And sine of 30, opposite of our hypotenuse for 30. 1 over 2. Then we smush the fractions together, just multiplying straight across the tops and across the bottoms. At this point, the denominator should be the same. If they're not, you've made a mistake. So then we can just put the tops together with that common denominator. It is the exact same answer as we got for number 1, yes. You will have lots of 1s, square roots of 3s, 2s, and square roots of 2s in your answers because those are the numbers in our triangles. So those same numbers are going to come up a lot in these answers.
Having the square root of 3, I had 1 minus square root of 3.
That is different. 1 minus square root of 3 is different than square root of 3 minus 1. Your answer would be the negative version of our answer.
So technically, the cosine of 75 is the same thing as the sine of 15.
Yes, the cosine of 75 is the same as the sine of 15.
Wait, are you gonna collect 14.3 ever?
No.
If you're doing like, what if you do like sine or cosine or whatever of like a really big number?
If you're working with a really big number, we might need to think about like 180 as being an angle that we could use, because 180 is in our unit circle, or even 270 is in our unit circle as well. So those are also valid numbers that we could use.
Could you use 360?
We could. We wouldn't usually use a 360, but we could because it's a unit circle number. Go ahead and try this example. It's in radians, so your first step is to make it into degrees, and then after it's in degrees, look for some angles that would add or subtract to give us that number. First thing we want to do is convert, so we convert by multiplying by 180 over pi, and that gives us what? 105. So then I want to find two angles that I know about that I could add or subtract to get 105, and what would that be? 60 and 45. Cosine sum formula. So under the sum formula for cosine, it says we're going to do cosine of each minus the sine of each. And it does not matter which order you did the 60 and 45, it'll turn out the same. So if you did 45 plus 60, you should end up with the same answer. So then 60 and 45. What is the cosine adjacent over hypotenuse for 60?
102.
Cosine of 45. Sine of 60, opposite over hypotenuse.
Square root 3 over 2.
Sine of 45.
1 over square.
Multiply together the parts, which just smushes them together. They should have the same denominator. So put the tops together over the bottom.
Minus 1 over.
Yeah, but you guys both said I was wrong.
So,
Is the next problem or last problem?
are there any questions on this one?
How did I get it right?
You know what? I will fight you.
The cosine of 60 is adjacent over.
Let's go.
Cosine of 60.
Yeah.
Cosine of 60 is adjacent over hypotenuse, adjacent to the 60. Is next to, so the 60 is down here, so adjacent over hypotenuse would be the 1 over the 2. Yep, we're going to do one more. All right, we're going to do one more example today, and then we'll save the rest of it for our next lesson. There are 3 different types of problems. So these 4 were our first type. The second type we're going to split, so we'll do one example of it today and then one to remind us of what was going on Friday to get started, and then we'll have our last type of problems. This question asks us to find sine of u minus v. So it tells us which formula we're going to use. So the first thing I'm going to do is write out the formula for the specific thing I'm going to ask for. So that would be sine of u cosine v minus cosine u sine v. Being very careful with the u's and the v's that they look distinctly different. That u's look like u's, v's look like v's, because it does make a difference. Then, we don't know what our angles u and v are. So unlike in the last questions where it was 30, 60, or 45, we don't know what angle they are, but we do know some information about u and v.
How did you get that equation?
That's just the formula from the formula sheet under sine difference formulas. So then what I'm going to do is draw pictures of angle u and angle v. So angle u, it says it's between pi and 3 pi over 2. So which quadrant is angle u in? The third one. Between pi is 180 and 3 pi over 2 is 270. So angle u is down somewhere in that third quadrant. The sine is negative 3/5. What's SOHCAHTOA for sine? Opposite over hypotenuse. So that means 3 should be the opposite, 5 should be the hypotenuse, and that 3 should be negative because it's heading downward. And then the third side will be negative 4 by the Pythagorean theorem. We did problems like this in the first half of our 14.3 lesson. So we're building off of that material here. Then I'm going to draw a triangle for the V information. It says it's between 0 and pi halves. So which quadrant is that? The first. And its cosine is 12 over 13. What's SOHCAHTOA for cosine? Adjacent over hypotenuse. So the adjacent should be 12. The hypotenuse 13. And our missing side would then be 5 by the Pythagorean theorem again. So now we still don't know what angle U and angle V are, but we know everything about angle U and angle V. So now we can evaluate from those triangles. So the sine of U, we look at the U triangle. Sine is opposite over hypotenuse, or negative 3/5. Times the cosine of V, look at the V triangle. Cosine is adjacent over hypotenuse, 12 over 13. Those were actually the two given pieces of information as well, so we could just grab those from the givens. But these other two were not given. So cosine of U, I look at the U triangle, and what's adjacent over hypotenuse there? Negative 4/5. And then sine of V, look at the V triangle, and opposite over hypotenuse is 5 over 13. Do not do any reducing at this point, even if it's possible to do some kind of cross-canceling. Don't do it. Multiply together the fractions. So negative 36 over 65 minus negative 20 over 65. Okay. Exactly. So we could have done some cross-canceling in the second pair, canceling out those 5s, but if we did that, we wouldn't have the same denominator, and then we're going to have to get the same denominator to be able to add them together, and so then it's just kind of going around in circles and adding extra work for ourselves. So don't do any reducing, because at this point you should have the same denominator, and if you don't, you've done something wrong. So now we have a double negative that we can take care of, and then we get negative 16 over 65. Reduce that answer if possible, but it is not possible. Okay?